So just briefly, to go back to the hypothesis testing steps, the one we've just covered is the statement of hypotheses. Now, the significance level alpha will determine for us the rejection region. So we will normally be considering what the value of alpha is. In your problems, you'll have this stated. The value of alpha, the significance level. N, of course, meaning the sample size, as it always does in our statistics problems. And then the thing that changes from test to test is which of the tests is appropriate. This is the thing we'll see over the next few weeks. From our value of alpha, we can set up the critical values and state the rejection region. And then in real life, what we do is go away and collect our data, and then from that, we compute the test statistic. So in our problems, we'll assume the data has been collected, and we'll be computing that test statistic. From the test statistic, making a comparison of that test statistic with the critical value, we make a decision, and then write our conclusion based on that decision. So we express the decision in the form of a conclusion, in the context of the question. Always going back to the context of the question, because that context is the bit that tells the story about what we've been doing. So, on to the first example. So here we're looking at a two-tailed t-test. Now, why is it a two-tailed t-test? And why is it a t-test at all? Remember that to use a t-test, we need a situation where we do not know the population standard deviation. Otherwise, we'd use a z-test, which is, of course, a t-test is a more normal way of doing this. But of course, when we're looking at sample statistics, this means we have the sample standard deviation, the value S, not the population standard deviation, sigma. So we have sample statistics here. The second thing to note on here is that we are looking at a claim that the mean volume of detergent is 810 mils. So we would say, is the mean equal to 810? That's our statistical question. And the opposite statement there is the mean is not equal to 810. Again, the idea of an inequality symbol, not equal, meaning it's a two-tailed test. Now, the next thing to note, having found our null and alternate hypotheses, we can then consider the rejection region. So note here that we have an alpha value of 0.01, and that we're going to be considering a test which is a two-tailed test. So bear in mind the numbers that we have there are going to be used to fill in this template slide for the hypothesis test. So the important things to note here, firstly, the mean is equal to 810 milliliters, as we wrote on the previous slide, and not equal to 810 for the alternate hypothesis. Our alpha value was 0.01. And furthermore, from that, of course, the test is a t-test, and that depends on degrees of freedom. Degrees of freedom, sample size -1. This was a sample of 16 bottles of detergent, so sample size -1 gives 15. So now we're looking at our rejection region, and the rejection region here is a two-tailed rejection region. We have an alpha value of 0.01, and so what this means is we're dividing 0.01 by 2 to find out how much we have in each end of the distribution here in our rejection region. So 0.005 at each end of the distribution. Now this is a t distribution, so we will have two values of t. One of them will be negative on the left-hand side, and the other one will be positive. They're symmetrically placed, and remember that this value in the middle here is 0. So here we're going to look at a t-table, which I introduced in yesterday's lecture. And this t-table will give us the critical value of t dependent or required in this problem. So we have 15 degrees of freedom. So we're here seeing 15 degrees of freedom, the line across there at the bottom of the screen with 15 degrees of freedom. And notice here we have an alpha value of 0.01. 0.01, be careful here because these values at the top, there's different zeros, it's easy to make a mistake. So we have the area in one tail is 0.01 here. Sorry, let me say that again. The area in two tails is 0.01. This is our two-tailed test, which means the area in each of the two tails, the area in one tail, is 0.005. And the number, the critical t-value here, is right at the bottom of that column alongside the 15 degrees of freedom, 2.947. So I'm going to insert the value here as a critical value, t equals 2.947, and on the left-hand side, t is minus 2.947, which means that we can reject our null hypothesis if the calculated test statistic lies in one of those areas, either beyond 2.947 on the right-hand side or smaller than minus 2.947 on the left-hand side. Now recall this is a t-test, so we're needing to use the test statistic, which we had in yesterday's lecture, x bar minus the mean divided by the standard error, which is sample standard deviation divided by the square root of n. Again, this formula is given in the formula sheet, so you don't need to remember it. So the formula here, using the information from this example, the sample mean is 807.64, which was in the problem on the previous slide. Our hypothesized population mean is 810, the number on the left there, and we're dividing by standard deviation 3.28 divided by the square root of sample size, which is 16. And of course, when you're doing these calculations, you'll always have Excel to use for this. So if I write the values down that I would get from here, you can use a calculator, of course, as long as you know how to, but Excel is always there for you if you don't have a calculator. You will not be required to do these problems on your own without a calculator. So what do we get when we do 807.64, take away 810, work out the top line first, that's minus 2.36, and working out this denominator value, 3.28, divided by, now the square root of 16 is 4, so 3.28 divided by 4, that's a bit less than 1. It's actually 0.82 to 2 decimal places. And so our calculated value there, when we divide the top line by the bottom line, is minus 2.88. That's a 2 decimal place accuracy figure. And of course, what we need to look at here is where does that value lie in our critical region? And of course, it's going to be over here on the left-hand side. No, it isn't. It's going to be on the right-hand side of 2.947. It's over here because it's closer to 0 than minus 2.947. So minus 2.88 is about there where I've put that red arrow. And so our decision at this stage will be do not reject, because our value, the test statistic, is inside the acceptance region. It's not in the rejection region. Do not reject H0 since our value is smaller than the criteria, the critical value on the left-hand side there. So do not reject. And this means we have evidence at this level. If we're not rejecting, we have insufficient evidence to reject the null hypothesis. And what that means in context is that we have insufficient evidence that the mean is not equal to 810. So we're not accepting that as the population mean, but we're saying we can't reject it. So we're saying we have insufficient evidence to suggest the mean volume of detergent is not equal to 810 milliliters. So again, remember that conclusion in the context of the problem. Go back to the question and write the wording from there. So that was a two-tailed t-test, as we saw there, because we were trying to determine whether the mean was equal to 810 or not equal to 810.